Be going over the infamous Tarzan problem that appeared in our momentum test today. A lot of people have messaged me throughout the day asking me to explain it, so I will. Now, what the question was asking was if Tarzan was swinging on a vine, starting here at a height of h, and he picks up Jane at, I believe the question described it as when he has the least potential energy. So in other words, when he's at his lowest height, or right here, when the string is completely vertical. Then how high will he come up on the other side? So we're looking for this height right here. And since we're given the first height in terms of h, I'm going to write this as h2. So we're looking for h2. Now, this is really not that hard of a question, but I believe what made it difficult for people was the fact that really it was misplaced in our momentum test today. Since really this is more of a general conservation of energy problem. Now remember, in any system, no energy is going to be lost or gained after an action. It's just going to be converted into other forms of energy, save for with the exception of the intervention of, say, wind, or like air resistance or friction, which generally so far we've just been told to ignore. But we can use that conservation of energy idea and apply it to this question right here. If we look at Jane as Jane's initial position here as part of the system, and we look at her total energy as 0, since she's at the bottom height here, then we can simply use that to calculate what h2 is going to be. So if we look at just Tarzan here, then at the moment, all the mechanical energy, all the total energy in the system is just represented by our potential energy formula. It's just going to start out as m1, which the question says is Tarzan's mass, times g times h. And if you want, you can write the plus 0 to represent Jane's energy. And this is going to equal the sum of Tarzan and Jane's final total potential energy. Since, again, they're going to equal the same. So here it's going to be Tarzan's final potential energy, so m1 gh2, since it's the final height, plus m2, Jane's mass, times g times h2. So now, this is pretty much all we need. Now all we got to do is algebraically solve for h2. So it should be pretty simple to do. We're going to first distribute the GH2s, since right now they're in different locations. So that can be written as distributed m1 plus m2. And then we're just going to divide the g and the m1 plus m2 out. So now it's going to be written as h2 equals m1 gh over gm1 plus m2. And since there's a g in the top and bottom, we can cancel those out. So now it's just equal to m1h over m1 plus m2. And this was one of the multiple choice options we had on that question. So that is your answer for m2.